Hey guys, today is our last section of our exponents unit, and today we're going to be talking about classifying functions. And this year you've talked about two different types of functions, and we'll go over those right now. Okay, the first one is going to be a linear function. A linear equation or function looks like this, and I need you to write this down. An equation with exponents equaling 1. An equation with exponents equaling 1. So an example of what a linear equation would look like is your slope-intercept form. Y equals mx plus b. Okay? In that equation, you don't have an exponent larger than 1. Okay? For example, your x variable, it would have an exponent of 1. Okay, so you need to know that it is a power of 1 to be a linear equation. A second type that you're going to see is an exponential equation. Okay, so put that in your blank. Okay, an exponential equation looks like this. Write down an equation with exponents equaling x. Okay, so your exponents will always be a variable. So an example that you might see is y equals 2 to the x. You have a variable for your exponent, so you know that that is going to be an exponential equation. Okay, so let's look at these few examples here and decide if they are going to be linear or exponential. Okay, our first guy, well, you have 3/4 x minus 1. You don't have a variable that's an exponent, and you don't have an exponent larger than 1, so this is going to be a linear equation. Okay, number 2, you have an exponent that is a variable, so that is going to be exponential. Okay, number 3, you have another one where a variable is your exponent, so that's going to be exponential. Number 4, y equals x. You don't have a variable that's an exponent, and you have your exponent as 1. Okay, so this one will be linear. And number 5, you don't have a variable as an exponent, but you do have a exponent that's larger than 1. So this is not either, so this is neither. This is called a quadratic if you care. We'll talk about that next unit. So this is a neither function. Okay, so let's look at this table of values and decide if we have a linear or exponential function. Well, we don't even need to graph it necessarily. We could, but if you look at this, actually let's go ahead and graph it. We have negative 2 times 4, so 4 times negative 2 would give us negative 8. 4 times negative 1 would give us negative 4. And 4 times 0 would give us 0. 4 times 1 is 4, and 4 times 2 is 8. So we can go ahead and graph this real quick. So we have negative 2, negative 8. Draw your point. We have negative 1, negative 4. 0, 0, 1, 4, and 2, 8. And so if you go ahead and connect these lines, that gives you a straight graph, so you know that this thing is going to be linear. Now you could have told that or realized that based on there only being an exponent of 1 and there not being any exponents that are variables. You could have assumed that that is a linear graph. Okay, so go ahead and move to the next page. Okay, on this guy, we have y equals 4 to the x. Well, we have a variable as an exponent. We could go ahead and graph this, and you'd get that horseshoe shape or the boomerang type graph, but we're not going to do that. Since you have a variable as an exponent, we know that this is going to be an exponential graph. Okay, so what I need you to know about our two types of graph. Okay, our first type of graph, a linear graph, looks like a straight line. A linear graph looks like a straight line. It will always be straight if it's linear. Now your second type of graph is going to be an exponential graph. Always looks like a curve. We talked about this yesterday a little bit. Okay, so a linear is straight, exponential is a curve. Okay, so let's look at a few examples real quick. Okay, so our first example, it's a straight line. Easy enough, we got a linear graph. Second one, it's curved, so we have exponential. And then our third one, it's curved, so we got exponential. And our last one, we have a straight graph, so we have a linear one. Okay, these should be very simple for you to tell the difference between them. Okay, go ahead and move to the next page. All right, the next thing we're going to look at is tables and deciding if they're linear or exponential. Okay, so I want you to look at the table on the left side. What do you notice about the x values? Okay, you'll notice that each time it goes up by 1. Okay, but over in the y column, if you look at that side, it goes up by 4 every time. Okay, so that's that table. Let's look at the other table. Well, you'll notice that the x values go up by 1 every time over here. But what happens over on the y column? Okay, you aren't adding every time. Okay, you're actually multiplying. So to get from 0.0625 to 0.25, you multiply by 4. You're going to multiply by 4 on all these guys. Okay, so what I need you to know about a linear table, and that's your first blank. A linear table looks like, let's go ahead and zoom in here. Okay, make sure you get this down. A linear table looks like the x value is constant. The x value is constant, goes up or down by same amount. Okay, a linear table, the x value is constant, goes up or down by the same amount. Okay, your next blank, an exponential table. An exponential table looks like the x value is constant. Goes up or down by same amount. Okay, so it's the same thing as your linear table. You're writing the same thing for the x value. Okay, so the x value is constant, goes up or down by the same amount. Okay, but the y values are a little bit different. Okay, for your linear, your y value is constant. Okay, so for a linear table, your y value is constant, but your exponential y value is not constant. Okay, when you have an exponential table, you're going to have it when it multiplies. I know this is a lot to write down. Okay, so your y value is not constant, it multiplies. Okay, so you need to be okay with that. So make sure you take a second to write. So let's take a look at a few examples on the next page. Okay, number 1, if you take a look at this, x goes up by 1 every time. And if you look at y, it appears that it goes up by 1.79 every time. Okay, so since it's the same on your x coordinate and your y, it's going to be linear. Okay, number 2, it goes up by 1 every time for the x, but it appears that it doesn't have a constant increase for the y. It goes up by 5,000, then 6,000, then 7,200, so it's not the same every time, so it's going to be exponential. Okay, and your last one, it goes up by 1 every time for your x, and it multiplies by 3 every time for your y. If you look, 10 times 3 is 30, 30 times 3 is 90, 90 times 3 is 270. So since it's multiplying by 3 every time, that's going to be an exponential table. Okay, the last thing that we need to do today is decide if something comes or is exponential or linear from a given phrase. Okay, so first thing, a linear situation looks like something that is in the form y equals mx plus b. Okay, so if it's in that form, it's linear. If you see words such as constant, change, per, every, or each in your sentence, then it's probably going to be linear. So constant, change, per, every, and each. Okay, so make sure you get those down. Okay, vice versa, an exponential situation looks like something where you have percent increase or decrease. Okay, so a percent increase or decrease. If it talks about half-life, which is a science term you might be familiar with. If it talks about doubling or tripling. Okay, so if you have percent increase or decrease, half-life, doubling, or tripling, it's probably going to be exponential. Okay, so number 1, it talks about the population of a fly triples. Okay, there's your keyword, triples over 6 hours. Since you're tripling, that's going to be exponential. Okay, number 2, it says you make $12 per hour working for your dad during the summer. Since you see that word per, it's going to be a linear function. And number 3, Miss Sharp, another math teacher, gets paid once per month. She gets paid once per month, so that's going to be a linear. Okay. Number 4 says you open a savings account earning 4% per year. Now I know this one says per, but it talks about increasing something by 4%. So since you have a percent increasing, that will trump the per, so that is going to be an exponential. Okay, and number 5, the path a soccer ball makes after being kicked into the air. Well, that doesn't have anything to do with anything, so that's going to be a neither. Okay, so that's what we got for today. Hopefully this will help you out in your homework. See ya.